Set in a river basin between the Andes and the coastal mountains, the spectacular capital city is home to about 43% of Chileans, with a population of 7 million in the metropolitan region, or RMS. It is the wealthiest South American city by per capita GDP. It has a Mediterranean-style arid climate with hot summers and fairly mild winters. The city is growing fast, by around 25 square meters every minute. It has around 9% poverty and the third biggest wealth divide in OECD countries. It has suffered in the last decade from a so-called megadrought. It was scheduled to hold the International Climate Conference of Parties, COP25, last year, but due to street protests about inequality this was cancelled and moved to Madrid. This short film will look at local climate projections, the vulnerability to risk of local communities, the impacts of climate change locally under different scenarios, and a brief look at future adaptation. The historic average warming in the RMS is about 1.3 degrees. The RCP Pathways projection shows an increase of between 1 and 3 degrees by 2065 and by over 4 degrees by 2100 under RCP 8.5. Precipitation in Santiago shows a projected decrease of up to 20% by 2065. The average curve for the RCP pathways does not change significantly up to 2100, however, because precipitation varies substantially in a country which stretches 4,000 kilometers from the Antarctic to the tropics. Cortez et al., using 40 years of historical data from weather stations in the RMS, created D-scale projections from international climate models in two IPCC AR5 pathways, A2 and B1. This is more regionally accurate, particularly regarding rainfall, which shows a marked decrease under both scenarios in every station. Warming projections are aligned closely to the larger scale models. Exposure to hazards will variously affect different communities, depending on their adaptive capacity. The lack of capacity of those at risk is a key element of vulnerability. Inostreza et al.'s report for urban policymakers in Santiago has created a heat vulnerability index. Using neighbourhood-scale GIS processes, it begins by identifying exposure to LSTs in the city, as well as urban vegetation, using NASA satellite data. It measures recognised sensitive groups such as the elderly, children, the disabled, people on low income, the less educated, and those living in overcrowded conditions. They are examined alongside adaptive capacity, measured through access to water, health, transport and communication services, green spaces, and residential building materials. The study shows a strong correlation between exposure to heat and vulnerability in the low-income neighbourhoods to the west, north, and south of the city, and an inverse correlation to the adaptive capacity of the higher-income eastern suburbs, where ironically it is least needed. The sensitivity correlation is less clear, but understandable given the varied nature of the parameters. Reduced rainfall threatens livelihoods in farms and vineyards within the RMS, and there is a direct risk to people in the built environment from extreme events such as heat waves and floods, both of which are already fairly common. In the near future, the RMS will be drier and hotter, with up to a 30% increase in the number of days over 30 degrees. Severe droughts have a projected increased annual occurrence of 60 to 70% by 2050 under RCP 8.5. Even at current climate levels, a central Chilean glacier has annual retreat rates of 125 meters. There is less streamflow in the rivers and an increased risk of flooding. With greater warming, health and mortality will suffer impacts due to higher intensity storms, heat waves and water scarcity, coupled with poorly designed urban infrastructure and lack of green spaces. Farmers leaving untenable land will migrate to the city, increasing uncontrolled expansion. The megadrought event has followed rainfall decreases of 20 to 40% per year in the last 10 years. Garrod et al. Ascertained that at least 25% of megadrought signals are down to anthropogenic forcing, with the rest attributed to natural variation, including El Niño and La Niña. The drought has major effects on water availability in all urban sectors and has measured health and socio-economic impacts. Political factors around inequality were a primary focus of the street protests last year. The RCP 2.6 pathway shows a best-case scenario for Santiago with least increase in local average temperature or decrease in rainfall, but action is still required to protect vulnerable communities. Krellenberg et al. Highlight the need for participation of local stakeholders in drawing up a plan for change. There is in fact not just a plan, marking out 14 concrete measures for adaptation in the RMS, but also practical implementation manuals.